This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Okay, welcome back. This is CS201 Introduction to Computing. We are in the fourth week. We will continue with new codes, new stuffs. So be ready, because things are getting harder and harder. Pay attention. Please download the codes from the professor's site. So there are no questions, I suppose. If there are about any inambiguities from the last week, please raise your hand and ask, okay? All right. Let me download them also. Questions? Yeah, of course.
Still carry your USB?
Yeah, I have one of your friends took it, so you can take.
I don't need it.
You can take it from your friend. All right. So let's go with the first example. Basically, just to warm you up, you remember the letter that we should have written last week. Let me remind you about that. So we have a program like this. Let me adjust the font. That is going to write the following letter. Okay, we're going to do it now, and we are going to enhance it. We are going to fix it, basically. This is what programming is about. You never write codes, basically. You develop the code, meaning that the code is constantly changing and improving, okay? So I'm going to write, we're going to see, just to remind you, what was it about. So we should write a letter that computes the interest for 30 days, 60 days, 90 days, if it's not paid. So you give the name, the surname, you give the date, let's say it's 20th of October 2016. The amount, let's say that it's $1,000. The interest is, let's say, 3.5%. And you should get something like this. Okay, you remember this stuff. You should calculate the interest for 30, 60, and 90 days. Okay, if you're not going to pay your bills in time. So our aim here was to introduce you to the functions. And functions were a cool thing to write when you have something that is repeated. As you can see, the date is constantly repeated. Also, this stuff here is repeated. So why don't we use a function to calculate and to write those three lines, and to write the date here, the date here, and the date here, okay? Someone would say, okay, why we are bothering that? I mean, straightforward. Yeah, it's like that, but just imagine if you have a long letter and you're writing like 100 dates or 200 dates, and suddenly your boss says, well, it's a good job, but I don't want to write it with dashes, with slashes. I want to write the date with full stops. So 20.10.2016. So you don't want to go through the code and change everything. You just change the function. It'll take you a couple of seconds instead wasting a couple of minutes. Okay? But there's a big problem with this program. Let me run it again. I have the executable version here. So I'm giving my name, my surname, and okay, let the date be the same. And amount, let's say that should pay minus 500. I mean, this makes no sense because you don't get a bill of minus $500. And let's say the interest is 3.7. So you should pay this much. Okay? Even worse. This doesn't make sense. What if I do something like this? Okay. But let's say that I should pay my bill on the 35th of 15th of 2016. This does not make sense. But the program accepts those data. Okay, the amount can be the same. The interest is minus 3.7. This doesn't make sense again. And this is the amount you should pay. This doesn't make sense, okay? Because interest should increase your amount, not decrease it. Otherwise, you are not going to pay your bills, okay? But first, let us deal with the program and let's fix those issues that we already saw, okay? So, let's start with a new project. I mean, you'll get the code. You can either choose to follow me or write with me together, okay? Which is more suitable for you, you can do it that way. I'm not going to change it. Oh, let me change the name. So it's week 4. Okay. I'm going to add a new item. Its name is going to be letter 1. And I'm going to write my code from scratch. So, let me increase the font size. I think this should be okay. Okay. IOStream using namespace, standard namespace. Okay, so I have integer main. Now we are going to play for the first hour with this piece of code. Again, let me run the code. So we should enter this program, prints a letter, blah, blah, blah. I'm going to write that stuff initially, so cout this program prints blah 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 till the end. I'm not going to bother with that. What else? Enter the following information. Cout enter the following information. New line. So I should read my name, but first let us declare the variables that we are going to need. We are going to need one variable which is called name. This is for our name, name, last name. This is it. We are going to need few integers. One of them will be day, for the day of the date, month, for the month, year, and amount. The amount is of integer type. Furthermore, we are going to need the interest which is going to be double, because it can be a decimal number, 2.5, 3.7, 3.5, whatever. And This is it. Okay. So I'm asking for the name initially. And I'm giving the name in the same line, yes. So when I give the name, I'm reading it now, yes. Let's go and write this piece of code. So name, and I'm reading the name. We have it. What's the problem? Okay. In order to work with strings, to read data and write data and so on, you should include the string library also. Now this should work. Yeah. Afterwards, we are reading the last name. Okay. So, cout. Last name. That should be in the same line. We are reading it. We have day, month, year. And we should read them in one line. So 20th of October, let's say 2016. Again, cout. Day, then month, then year. Cin. We are going to read the day. Again, we are going to read the month. And we are going to read the year. Right. Amount. It should be an integer. So cout. Amount. Afterwards, we have the interest. Let's say 3.9. And we print the ladder. So we have the interest. We read it. And afterwards, we are going to print the ladder. We can define a function here, which is going to be called print ladder. But before doing it, let me return 0. Then cin ignore cin get in order to see the output. And I'm going to write the function print ladder, which is going to print and do all the stuff for us. This function is going to take as a parameters all our inputs that we just gave to the system. So it's going to be what we gave first, the name, then last name, then what did we have else? The day, the month, the year, day, month, year, the amount, and the interest. This is just to show you that we might have multiple data. But as you can see, we have a mistake here. Print ladder is undefined. Because we don't have it. I mean, the compiler is confused. That's why. Let's write a function which is not going to return anything. Basically, it's going to print the letter. And it's going to take all parameters that we just saw. So it's going to be void, because it's printing. It shouldn't return anything. Its name is going to be print letter. And now see, I'm sending those data But print letter doesn't have any parameters for the time being. So name is string. That's why I'm going to say that I have data which is of type string. It's going to be called name inside the print letter function. It can have another name, yeah. Then we have what? Here we had string last name. String, we can call it surname here in print letter. Okay. Then we have what? Day, month, year, amount. All of them are integers. Again, we can use the same, or we might choose to use another name. So integer day. Let us put the same names, month and year. What else do we have here? You see, though we don't have red dashes here, but we have here because we didn't put any amount. We didn't define them here. The amount, which is also of type integer. So again, integer amount and integer interest. We don't have any red underlines here. So let's go with the function. What do we have initially here? Initially, we are printing the date. Okay? Yep.
Why is interest int? Why is interest int?
Interest is
It'd be double. Yeah, you are right. It's wrong. But you can. Why don't we have white dashes? Nice question. Very nice question. Why don't we have white red dashes here? Because you can convert it from double to integer. In what manner? You just slash the decimal points. Okay, the fraction, the decimal part of the number. Okay, that's why it's convertible automatically from the compiler. But nice remark. Yeah, it should be double. You're right. So if I give the interest as 3.7, it would have been here as 3.0, which is a mistake, of course. Print letter. Now I'm going to print the date 3 times. That's why I want to define a function which is going to be called print data, print date, and then I'm going to send the day. I don't have to declare. I mean, I know that day is already integer. That's why I'm going to send it like this, day. So when I'm calling the function, I should not tell to the compiler that, okay, this is integer, this is double, this is string, because it already knows it. But this is when I'm calling. You see, I'm calling print letter here. But when I'm defining it, declaring and defining it, I'm defining it right here. I should say that this variable is of type string, this one is of type integer, the other one is of type double, okay? But when I call it, I don't have to do it. So again, I'm calling the print date function here in order to print this date here. So this is the first line of our code. So I'm calling print date, I'm setting day, month, and year. Already inside this function, we know that all of them are integers. That's why I'm going to use another function, which is going to be called print date. And now this function takes parameters as follows. Day, again, we can give another name. Let's say it's D. Integer M stands for month, and integer year Y stands for year. The format is the following. We print the day / month / year. So cout. I'm printing the day, D. Then I'm printing this stuff here, the /. I'm printing the month. Again, /, and I'm printing the year. Do I have to use a new line here? I need it here, I need it here, I need it also here. Yes, I need it everywhere, so I'm going to use new line as well, and line. This is it. Okay. After printing the date, we should write the following stuff. Dear Artyom Kamili, our record shows a balance of blah, blah, blah. Let us write it. So, cout dear, and artims is the name, so I'm printing the name. Again, there should be an empty space between the name and the surname, you see. That's why I'm writing this stuff here, the empty space. I'm writing the surname. The surname is known here as surname. Okay. Then I'm writing this stuff. Empty space, 2 points. I'm going to a new line. What do we have here? Our records show a balance of, this is the amount that I gave. Okay, so cout our records show a balance of the amount is known as amount here. As of now I'm printing the date. When I'm printing the date, I'm finishing here. I'm not going to a new line because the date should continue immediately after this empty space, after the blank space. So I'm calling print date again. And the date is the same as here that I took as parameter. So I'm calling it again. I'm setting day, month. And you see it's expecting, you know, when I defined the function print date, it takes D, M, and Y. And it's shown here. Hope you can see it. So D is integer, M is integer, Y is integer. That's why I'm expecting to send integer, integer, and another integer. It's here. So inside, again, inside the print letter function, it is called as day, month, year. But when I call it with those parameters, inside the print date function, it's going to be the same. Those data, those variables will be known as D, M, S, Y. Actually, they are not the same. They are clones. Okay? It's like copy-pasting stuff. We have it here. We copy them. We put them here. They're not the same. So if I delete D or change D here, it will not be reflected here. Okay. In order to avoid any late penalty, please pay. So this is it. I'm going to provide this stuff also. In order to avoid any penalty, please pay. What should I do? Please pay your balance in full until. Please pay your balance in full until. Now I should print something else. I should calculate what? Due day, due month, and due year. How do I do that? You remember it from last time. So you should check the videos again. Due day, the day is the same. Due day is same as day. For due month, you remember if the due month was 12, it should be 1. Okay, so but the year should be increased by 1. This is from the last week. So due month is equal to month modulo 12 plus 1. Modulo gives you the remainder. Month should be written like this. Okay. I forgot to tell the type that those are integers. This is also integer. Okay. And I have another integer. Due year is going to be the year plus month divided by 12. Okay, so I have all of those data. I should print this day here. Again, I'm calling print date. Now I'm setting this stuff. You know, see, it's 20th of October, but the due date is 20th of November 2016. So I'm setting the newly calculated variables. It's due day, due month, and due year. Okay. Then we're printing this stuff here. Otherwise, we have to charge a late penalty. So see out. Otherwise, we have to charge a late penalty monthly. Now I'm printing the interest here. I can do it like this. It's more readable. This is the interest. Percent. Closing the bracket, the parenthesis, as shown below. Okay, this is it. Now, you see that I'm repeating stuff here. That's why I'm going to write another function. And I can call it print penalty. Since it's printing and also calculating inside, it will be void. Void meaning it doesn't return anything. But it's calculating, doing some calculations inside and doing some printing stuff. Print penalty. What do you think? What should I send here in order to print this stuff? Should I send the amount? Yes, because I cannot find the interest without the amount. Should I send the interest? Yes, because I need it for this stuff here. And I should send the number of months here. I mean, 30 days is 1 month, 60 days, 2 months approximately, and 90 days is 3 months, okay? That's why it's going to have 3 parameters. I can call it here the balance, which is the amount. Well, let me do it, okay. I'm going to use another name just to show you that you can use other names. Balance, the interest, which is, this is the monthly interest. I'm going to use another name on purpose here. And what else do we have? The month. Integer number of months. This is it. So first, I'm going to call this print penalty function. See, I'm calling it 3 times. And I have one end line, I go here, another end line, I go here. That's why I'm going to have 2 end lines here. Of course, there are other mistakes that I left on purpose. Mistakes, not mistakes. Maybe the letter output will not be as here, but we're going to fix it. Now I'm going to call the print letter print penalty with, what should I send first? Balance. So amount, interest. I'm sending the interest. And I'm sending number of months, which is month here. No, number of months is going to be 1. It's about 30 days, 40 days, 30 days, 60 days, and so on. Again, I'm printing print penalty. Let me copy and paste this stuff. It's the same. So I'm copying it, pasting it again. For 2 months and for 3 months. We are going to define a new variable here. This is double variable. I'm going to call it late amount or new amount. So double late amount. You remember the formula for this guy was the following. Late amount is equal to, of course, what should you pay, plus add it with the number of months, add it with the balance, multiplied by monthly interest. Okay, this is the interest for 1 month, but this guy should be divided by 100, since, okay, this is only for 1 month. But if I have, this is the extra amount that you should pay for 1 month. Okay, so balance multiplied by interest divided by 100, since the interest is 3.9, which is 3.9%. Okay, this is 3.9 divided by 100. This is for 1 month. For multiple months, for 2, for 3, of course, I'm going to multiply all of this stuff. So number of months multiplied by this guy divided by 100, and I'm going to print this. So see out 30 days. This is 1 month. What I'm printing is the following: number of months multiplied by 30. So if number of months is 1, as I gave it here, I'm going to print 30. If it's 2, as I gave it here, I'm going to print 60. If it's 3, I'm going to print 90, just as is the case here. So number of months, and I'm printing it. Days past due, you pay, blah, blah, blah. Days past due, so you pay, and I'm paying the late amount. We have end line. This is it. What else? Best regards, CS201 Corporation, and I'm doing it here after I'm paying the amount. So see out. Again, I have new line, end line. Then I have best regards. Then I have 2 new lines. Then I have CS201 Corporation. Okay. I hope we don't have any mistake. So let's run the code and see whether we are getting what we want. There are no syntax errors. Let's see for... Yeah, I'm a bit fast. You'll have the videos. You will have the videos. It's important to understand how I did this stuff, okay? And if you have questions, please raise your hand. So far, so good. Everything is the same. I'm giving my name. Okay. Then I'm giving my surname. Just as it's here, you see? They're doing both the same thing. So name, surname, last name, blah, blah, blah. Day, month, okay, let's say it's 20th of 2016. Amount, 2,500, interest 3.7. Oh, there's a mistake. Let's see, I don't know what's a mistake. I'm using the variable without initializing it. Wow.
When you write late amount, code late amount plus,
Yes.
it has to be balance plus.
Oh, you're right. Yeah. This is the balance. Yeah. You're right. It should be balance. You're right. Because I'm charging the penalty on balance. Yeah. I changed the name. You know, the name here was amount. So yeah, you're right. It should be balance. You're right. So this was a good syntax error, logical error. Okay. This is it. So The mistake was that I didn't initially, I'm using late amount here, but initially I didn't give any value to late amount. And now, since I have the value of the balance and monthly interest and month, I'm just calculating this stuff. Yes? Okay, again. Amount. Interest, let's say it's 3.7. Let's see, yeah, it's pretty much the same, but what's not the same? I mean, let's do some makeup for this. You see this name and last name and amount. We should have n lines after each of them. We are going to fix it here. So name, n line. We have another n line here because we have n lines. I mean, this is not important, but let's just fix it. N line here. Also, you see the date that should be printed here in the end. It's printed here. We can do it in many ways. I don't want to bother you with some details about it. We can go here before printing the date. I can print something like this, a lot of empty spaces. I mean, there's a better way of doing things, but this is also okay. What else? I think it's pretty much the same. Yeah, approximately it's the same. That's why. Let's stop this guy, let's run it again, and hope we have what we want. Okay. So you see where we have those new lines, the day, the amount, the interest. Yeah, we can send it a bit more to the right, but everything, the rest is pretty much the same. Okay. Any questions? Now we saw the mistakes. What if I give for the month that I should pay the bill at the 15th of 15th? Or what if I say that the amount is a negative number? Or February, does February have 30 days? No. We are going to fix this stuff in a while. Before doing it, let me just, before taking a break of 5 minutes, let me introduce to some interesting stuff. And those are if clauses. Do you know what if clauses are about? Have you seen them? Okay. Sometimes you don't want to execute all of the code. If a certain condition is fulfilled, you want to execute something else. Otherwise, you want to execute something else. These are where you are using ifs. The syntax of ifs is the following. We have a condition. This condition, this statement here, can be true or false. If this condition here is true, this part is executed. Otherwise, if this is false, this part here. So the syntax basically goes like this. We have if, let's say that we have a condition here. And this condition, by the way, can be true or false. If this is true, code for true is executed. Otherwise, if it's not true, this block is skipped. And this block is executed, okay? So we have code for false. I think we should record this one also. Again, if the condition is true, we execute this stuff here. If the condition is false, we execute this one. Okay? Code for false. Well, you can skip the else clause. There are some codes here. One of them is the following. We give two numbers. If number 1 is greater than number 2, then I'm saying the maximum is number 1. Okay? Let me enlarge it. So I'm reading two numbers and checking whether number 1 is greater than number 2. If number 1 is greater than number 2, then maximum is number 1, and I can print, well, this is the maximum, else I'm saying the maximum is number 2. Okay? Which are the conditions that we can use? Those are. So you remember we have integer types, float types, string, and so on, and all of those types have had their corresponding operations. Well, we have another type, booleans or statements. We can use those operators with them. This is less than or equal, and so on. Okay, equal. Just pay attention. This is equal. Don't mix it with only one equal. This is equal. Yes.
Are these standard, or do you have to include some sort of other?
No. These are they're incorporated. They're inside. You don't have to include any library. Okay. If I say something like this, a is equal to 5, what I'm doing is the following. I have an integer, let's say, or any type. Let's say this is integer, and I'm saying that, well, a is 5. Okay, this is the assignment operator. I'm assigning values. But if I'm saying something like this, a equal 5, basically this is like a question mark. Okay, and this can be true or false. If a is 5, and then if I'm writing something like this is going to be true. But if I say that a is equal to 6, and I have 6 here, and I'm asking, when I'm saying, and this is a statement, that 6 is equal to 5. Is this true? No. So it's going to be false. Don't mix those two, okay? This is the assignment operator, and this is the operator for asking whether it's true or false, equal. Now, let me briefly run a piece of code, write a piece of code, and I'll give you a break of 5 minutes, okay? This is important. We will continue with the example. I'm going to start a new code. We will have it here. Yeah, I'm going to save it. I'm going to do it in like 5 minutes. It's very important to understand this piece of code. That's why pay attention. You don't have it maybe on the web. If you want it, I can put it. But I don't think that you'll need it. You don't have to write anything. Just follow me. So again, include IO stream using namespace std integer main. I'm going to define a number, which is going to be called number. I'm going to read it. So give a number. I just want to show you how ifs and else's work. We will deal. I mean, the topic of today are those statements, if else. So give a number. I'm reading it. You cannot do your homeworks without knowing really good this stuff. I'm reading the number. Now I want to check whether this number has 3 digits or not. Okay? So I'm going to write a statement like this. If the number is greater than 99, and just pay attention again, this is an integer. So if it's greater than 99, what can it be? It can be 100, 101, and so on. So if it's greater than 99, I'm going to print this piece of code is going to be executed, and I'm printing cout. It has 3 digits. Otherwise, I'm going to print cout. It has 2 digits. This is it. Return 0. Let's run the code. And I'll give 102. And yes, it has 3 digits. Okay. Because 102 has 3 digits. If I run the code again, and I give, let's say, 5. Oh, it has not 2, 3. It has 2 digits. Or it has less than 3 digits. Okay. Oh, exactly. This is what I was trying to show to you. Instead of number is greater than 99, I can use, the logic, the program is going to remain the same. It's going to give the same output. If I say that number, if the number is greater or equal to 100, then I have basically the same thing. So yeah, if I give 100, it has 3 digits. Now, is this working in a proper manner? What if I say something like this? 2500. It has 3 digits. Is this true? No. Okay. Then what should we do about this stuff? There's something else. Yeah, we saw the relational operators, but there's something else. And this is what we're talking about. Maybe you have seen this stuff at your high school. Have you ever heard about Boolean algebra or logics? Okay. I'm going to write the truth tables of something which is called an AND operator. So this is A and B. And logically, we're going to see the truth table of them. Let's say I have a statement. The first statement is the following. I'm 30 years old. 30 years old. And I am 30 years old. Let's assume it. What if I say I'm 30 years old? This is my statement A. And my statement B is, and I am a female. Is this true? But I'm 30 years old. And I'm a female. Is this overall true? So the first statement is true because I'm 30 years old. Let's assume I'm 30. I'm not going to give you my age. It's going to be in your midterm. You should find it. But, well, let's say that I'm 30 years old and I am a male. Is this true? Yes. That's why A and B is true. Okay. What if I say I'm 30 years old and I am a female? The second statement is not true. But I want to combine them in something which is more complex stuff. And I'm saying I'm 30 years old and I'm female. Is overall this statement true? Logically, yes or no? No, exactly. So this is false. What if I say I'm 5 years old? This is false. And I'm a male. And this is true. Is this overall statement true or not? No, this is false again. What if I say I'm a child? I'm not a child. Okay. And I'm not a female. So both of them are false, this is false. Okay, this is when we are dealing with AND. Okay, and AND is written like this in C++. Now let me write another truth table, A and B. And I'm going to call this A or B. And OR is written like this in C++. So this is ampersand, double ampersand. We have here vertical bars, double of them. Again, let's make them true and true. I am a female. No, I am 30 years old, or, I'm not saying and, or I am a male. Is this overall statement true, logically? Yes. What if I say something like this? I am a male. No, I'm 30 years old, or I am female. So one of them is true, the other is false. Don't see those tables. Just logically think. I'm saying I am 30 years old, which is true, let's say, or I am female, meaning in Turkish it's veya, I think. Either that or that. So overall, is this statement true or not? I'm 30 years old, or I'm female. It's true, because if you go and order something, you can say, okay, you can give me a juice or a Coke. Maybe the waiter will give you only juice, but not the Coke. But if he brings you the both of them, it's okay, better. But if he brings them only one of them, it's still okay for you. But if you say, I want a juice and a Coke, he should bring both of them. If he says juice or Coke, only one of them is sufficient. So true or false is true. The same applies with false or true. It's false. And false or false, what do you think? If I say I'm 5 years old or I'm a female, this is false. Okay. Remember those truth tables. And let's go to our coding stuff. You have it here. Okay, so in order it to have 3 digits, the number should be greater or equal to 100. And what else? And, come on, help me. In order a number to have 3 digits, what should be true? It should be greater or equal to 100 or greater than, and what else? Smaller than 1000, exactly. So the number, I'm writing parentheses because still we don't know the precedence, I mean which has priority, that's why I'm writing them. It should be smaller than 1000. So if I execute, so this is statement A and statement B. You can find the ampersand using shift and 6. Did you find it? Let me execute the code. Again, so if I give 1005, it has less than 3 digits. This is logical mistake, yeah. But why it's like that? Because when I'm executing this piece of code, this is false and false. This is not going to be executed. We go to the else and we do this stuff. Now we want to be more precise. That's why we're going to do something like this. Else. So if it doesn't have 3 digits, it might have 2 digits or 1 digit. So I can write something like this. If the number, in order to have 1 digit, what it should do is smaller than 10, then I'm going to print it has 1 digit. If it doesn't have 1 digit, it might have. That's why I'm writing else another if. If the number is smaller than what? Smaller than 10, we saw it. It has 1 digit. Smaller than 10, meaning from 0 to 9. Assuming that we are giving positive numbers always. 100, of course. And I'm going to print it has 2 digits. Okay. So if this if is true, all of this if, with both those statements, you can assume this is one statement, this is going to be executed. If it's not true, it goes to the next statement, we have else. But after the else, we have another if. If this is true, this is going to be executed. We don't bother with the other ones, okay? But if this is not true, we go to the else. And after else, we have another if. We try it with another if, okay? Is this clear? How many of you understood this stuff? Very nice. You're not going to have problems with your homeworks if this is the case. But there's another error here, logical error. Let us fix it together, and I'll give you a break. If I'm giving 10,000, I'm not printing anything. So I want to have something for 3 digits, 2 digits, 1 digit, and something more than 3 digits. So what should I do? Else, yeah. Just else, exactly. You can write, I mean, if it doesn't have 3 digits, if it doesn't have 2 digits, if it doesn't have 1 digit, it's going to have more than 3, because we're starting from 0, assuming that the number starts from 0. That's why we don't have to check it again. It's for sure. So we can write else cout, it has more than 3 digits, 4, 5, and so on. It has more than 3 digits. Of course, you could have done something like this. Else, if more than 3 digits, that means it's greater than or equal to 1,000, or greater than 999. So you can write something like this: if number is greater or equal to 1,000, then it has more than three digits. But even if you don't write it, it's okay. So if I give 1005, this does not apply. Then I'm going to this one. 1005 is not smaller than 10. This is false. So I'm going here. 1005 is smaller than this one. So I'm going here. 1005 is greater or equal than 1000. So I'm going to print it. But even if I don't put this guy here, still this will be printed. Okay? Now I'll give you a pause of 5 or 10 minutes. 5 minutes. We'll be back. Okay? You can ask questions.